Hi, welcome back to my channel. Today we are going to talk about Java streams and low-level details of Java streams. And Java streams are basically depending on functional programming model that is called functional interfaces. And there are certain existing collections has been modified to support these features. Let's dive in. So the prerequisites are you must need to run these labs JDK 8. In my case, I'm using JDK 18. Your favorite IDE, you can choose it either IntelliJ IDEA or Eclipse. Intended audience Java developers, senior developers, architects. So Java 8 release brings with loads of features, so which we are not going to talk about all. We are going to focus on only streams. Streams are one of them which we are discussing now. A stream implementation is permitted significant latitude in optimizing the computation of the result. That means as much as low memory footprint to be used to build your result. That's how optimized JVM compiler as well as JVM runtime engine. That is the beautiful thing which will be avoided a lot of boilerplate code like the legacy Java implementations. We will see some samples after this concept understanding. Stream builds a pipeline operation. That means stage by stage. A stream begins, a stream ends. In between, there are different operations can be performed by the application. Say based on some conditions, you can filter some data, or you wanted to transform the data, you want to do the aggregation, you want to do the count, whatever it is based on your use case, and you want to sort your data. Example. These things happen stage by stage process from beginning of the stream, ending of the stream, in between the pipeline builds. Okay, the pipeline can run in based on the type of the stream which we are using. One is a serial stream, other one is the parallel stream. So that is what I have written here. Serial streams are classified into serial and parallel. Serial means one by one it will perform. Parallel means at the same time your data gets split into multiple stages and then performed or computed and then results given back. So streams support no side effects. What is mean by side effect? That means say I have a records of 10 bunch. From the 10 bunch, based on some logic, I'm going to reduce 5 records. That means you are not going to change any of the data. Say I have a record of three fields: ID, name, and salary. Example. So 10 records are there. Based on say employee's salary basis, whoever salary is more than some number, you wanted to filter it. Only those 3 records or 5 records or whatever it is based on the logic you will be filtering out. So that filter is a staging operation. Okay, and then you will be just getting it. You are not changing the data. All the 10 records will be deriving now into 3 records based on the logic evaluation which we are doing it. That we call it as a no side effect. This is heavily used in the functional programming model, that is from any language, either Java 8 or Scala. So functional programming model in Java, they have implemented using functional interface annotation based approach. In Scala, they inbuilt they have used functional programming model to do the same kind of a thing. So in case if you are going to change the object structure, say you have the salary, you wanted to change the salary of the person of a particular ID, that means your record is getting changed. This is violation of the functional programming model. So that kind of operations also we can do it whenever you are doing a count or for each. these are possible to do the effects of your actual data, that we call it as a non-functional programming in that particular piece. So let us work with this. Streams are heavily working with functional interfaces programming model and lambda expressions. Whatever the code which we used to write as boilerplate, that has been reduced to simplify in a single line of a code, or you can use the staging operations that we call it as lambda expressions, where there is no side effects. And the package structures they have introduced for the streams, Java util stream, for functional programming model, Java util function, and they have modified a lot of collections, list collection, and they introduce a stream. This is going to be heavily implemented. A lot of utilities also built it. I am not going to talk about all those things. Let us focus. Any collection object transformed into a stream, then apply different types of operations. As I was talking, beginning of the stream, ending of the stream, in between there is a pipeline operation. In the pipeline, there could be these operations could occur. Intermediate operations, map and flat map of the stream objects. If you apply stateful intermediate operation, that means say you wanted to sort your data sets. So you need to manage and maintain and preserve the data. So that time you need these operations. Say short circuit terminal operation. Terminal means your pipe begin, your pipe ending. That means your job is computed and done it. So that we call it as, or in between. Short circuit means it will not 100% invoke your begin to end. Somewhere else it comes in the halfway, and then your job is done based on the logic. That we call it as short circuit terminal operation. Short circuit stateful. There is a short circuit happens, but your data has been preserved until that what we have been modified, and then followed by terminal operations. So terminal operations, here few examples I am giving. Please revisit or go through the documentation. Reduce, count, min, max. Now let us try to understand the stream inheritance, how they have implemented. Stream inheritance, base stream is the class, interface, sorry, and then stream, int stream, long stream, double stream. There are a lot of utilities they have modified. Okay, so where you can download the Java. Now let's dive into the hands-on. Okay, I'm going to create a package, streams. For example, already I have a package structure where I'm creating streams is one package. Here I'm going to build one main class, Java streams. Okay, I'm going to have a main driver here for testing list. Then I'm defining of my type integer int list. I'm specifying equal to, this is list of is also introduced in Java 8. It is a immutable list, 1 comma 5 comma 3 comma 4 comma 2. Say this is my collection which I have defined it. Now let us try to focus and understand one by one operation. Say I want to sum of these all the numbers. How do I am able to do that sum of? Earlier we use int list using a for loop, and then introduce a new variable sum, and then we do the calculation, traverse each element, and then do the sum, and then aggregate, and then send it. Now that has been simplified. Int list dot, as I was talking, stream or parallel stream. Make sure that parallel stream works with the threading. Your hardware should support good amount of system resources to perform with the parallel stream. If not, the program could terminate intermittently. Definitely interrupt. can happen. So make sure that you have the appropriate threads being added. There is a system parameter which supports during the parallel stream. Make sure the corresponding threads which you are setting as a system properties. Okay, parallel fork new parallel thread, there is a property exactly name. I'm not going to describe now here. Okay, so now let us go with the stream. So what I wanted to do it, I wanted to do the sum. As I was talking, there are many operations, right? Stream, reduce, collect, flat map, map, sorted, filter, all match, none match. These are all I already described over that. Now say map to int, because I wanted to do the sum x. I'm just saying x is, this is called a lambda expression. Then I'm applying sum. So directly I'm getting a result. I get the result. What is the result? I'm just going to print sum sum. Now I will run this exercise. Before I run it, okay, let me do as another stateful intermediate operation. Okay, so I am streaming, then sorted. So I want to sort comparator dot compare x colon x dot collect. Let me break this up so that you can see. Collect also intermediate operation to list. So here I am using shortcuts. If you know the shortcuts, you can use it. So now sorted list. I use sorted list. Now I have performed a couple of operations. Now I will show you one more operation, just a short circuit operation. Match. I have to write a predicate. X greater than x. So as I said, I'm just using the predicate model shortcuts. Sorry, let me delete that code. So whether it is exist or not, any match or none match, you can choose anything. Okay, boolean match. So I can now, I'm applying a serial stream. Now I'm going to run this sum. So this is preserving the state. You can see that status is being preserved, which order. Initially I have 1 5 3 4 2. After sorting I got according to the ascending order. If you want to descending, you can say reverse here, reversed. I'm not doing it right now. And I have built a computation of summing of all these numbers. So with a simple map to int and then applied the aggregation operation. Here I can apply average. If you want min, max, like different types of things, you can apply it. Okay, I'm not going to do all those things now. I'm just telling to you. And then now you see, is this any of the element greater than 6? No. But if I'm going to change to 4, I can see that means even though 5 is the second element, I'm not performing all the 5 stages. Only the second stage itself successful, and then results I got. If it is this, I got the true because more than 4. So first element is 1, false. Second element is 5. 5 greater than 4, yes, match it. And short circuit terminal operation successful. It will not traverse now further elements. That is how these are being developed. Okay. Thank you for watching the real-time hands-on concepts and then followed by the lab exercise. And that's all at this moment of time. Please like it, share it with your friends, and subscribe. Thank you. Bye bye.